Professor Adler, you are with us. I am seeing you.
I am here.
Good morning, Professor Adler.
Good morning, good afternoon.
Good afternoon. Yes. Good morning in Clemson, South Carolina. And good afternoon in Algeria again, Mom.
Thank you very much.
I'm very happy to see you again.
Thank you. You might see that outside it is still very dark. The sun has not yet come up.
Oh, okay. Okay. As usual.
As usual.
As usual. Thank you so much for joining us, Professor Adler. It's
My pleasure.
It's a big honor for German and our the scientific community. Unfortunately, you are not able to join us within the beginning of ceremony, taking into account the difference time between Clemson and German. So Professor Adler, as I said this morning, is the president of the scientific community and the honored guest of the conference. And he is my co-promoter of my thesis. And I have with Professor Adler a long history of personal relationship, more than academic and scientific relationship. And I am very, very happy to see you with me. And despite his many and several duties, he accepted to be with us today. Thank you so much, Professor Adler.
It is my pleasure. Thank you very much.
Thank you. So, Professor Adler, the next keynote will be presented by Professor Adler, Professor Peter Adler from Clemson University, South Carolina, United States of America. Professor Adler will present us a keynote titled Simulated Diphtheria in Algeria. Unknown biodiversity, unknown medical and veterinary risks. Professor Adler, you can start.
Thank you very much, Nuna. Can you hear me?
Yes, of course, perfectly.
And you can see the presentation,
yes? Of course. There is no technical problem, don't worry. Everything is fine.
Wonderful.
Thank you.
Wonderful. Greetings, friends and colleagues. It is a great pleasure to join you today from a distance of 8,000 kilometers on a different continent across an entire ocean. And I especially would like to thank Dr. Muna Cheraria for inviting me to this very important and prestigious conference. This subject matter, the risks of medically and veterinarily important insects, is of worldwide importance, global importance. So I'm delighted to be able to participate. Thank you very much, Nuna, for the invitation.
The honor, the huge honor is for me. Thank you so much for giving us this opportunity. Thank you so much.
Thank you. I'm going to speak today about one group of medically and veterinarily important insects. That is the family Simuliidae. And I would like first to put the family Simuliidae into a larger context. If we look at the number of insect species in the world, we see that more than 1 million species have been formally described. Of those more than 1 million species, nearly 160,000 are diptera, that is flies. Of these flies, approximately 14,000 take the blood from birds and mammals. And of these nearly 14,000 blood-feeding diptera, more than 2,400 are members of the family Simuliidae. And you will see, highlighted in yellow, that Algeria currently has 33 species of Simuliidae. I would like to emphasize, however, that these numbers are going to increase, and increase significantly. We can expect the number of species of Simuliidae in the world and Algeria to increase, probably dramatically, as we continue our studies. The study of Simuliidae involves all aspects of their lives. everything that we can understand about the Simuliidae, including where they live, their ecology. All Simuliid species breed and develop in flowing water, freshwater streams and rivers. The eggs, the larvae, the pupae, all develop in flowing water. The terrestrial stage involves the adults, the female Simuliid and the male Simuliid. Investigations of Simuliidae are at different scales: an ecological scale, an organismal scale, a chromosomal scale. As you see here in front of you, there is an image of giant chromosomes from the larval salivary glands, and it also involves the molecular level, that is, the study of DNA. Something as simple as DNA barcoding or more sophisticated molecular techniques. Let's look at the occurrence of Simuliidae in Algeria. Nearly all Simuliids in Algeria are found in the mountainous areas or areas near the mountains. And specifically, this means the Atlas Mountains along the northern border of Algeria and the mountains that are within the vast Sahara Desert, and in particular, the Hogar Mountains. In these mountain areas, probably the most species are found in the Tel Atlas Range that runs along the northernmost border next to the Mediterranean Sea. The Tel Atlas Mountains have many species of Simuliids. All of the 33 species so far known can be found there, and there are species that we think are endemic to the Tel Atlas Range. That is, as far as we know, found only in Algeria. In the Sahara Desert, there are Simuliids, and I would like to draw to your attention a publication that was in PLOS One that discusses the occurrence of Simuliids in the Sahara Desert, specifically in the Hogar Mountains, where Dr. Chavarria worked intensively to survey populations of Simuliids. She found them to be abundant, and there is genetic documentation and ecological documentation in this paper in PLOS One, if you wish to consult it. The medical and veterinary importance of Simuliids is related to the need of the female flies to have blood in order to mature the eggs. Therefore, the biting and cutting mouth parts of female Simuliids that are used to obtain blood can cause great damage to hosts. The hosts are birds and mammals, including humans. And so this quest for blood drives two important aspects of Simuliids in the medical veterinary world. One is as parasites, specifically as biting pests. As I said, biting pests of birds, mammals, including humans. Not only biting, but also swarming and causing distraction, which results in economic losses. The other aspect of Simuliid medical and veterinary importance is the role of these flies as vectors of parasites. In other words, we're talking about vector-borne diseases, the most significant of which is human onchocerciasis, or river blindness, which is shown in the image on the right of your screen. This horrible disease is caused by a parasitic worm known as Onchocercovolvulus that is transmitted by the bite of a female Simuliid fly. This is an example of the extent of attacks by simuliids on humans. Now, fortunately for Algeria and North Africa, this level of simuliid attack has not been documented. These levels of attack are known primarily from northern latitudes and certain areas in the tropics. Nonetheless, I emphasize that many of the 33 species known from Algeria will feed on humans, so there is the possibility for simuliids to be attacked, although, again, we have not documented this level of attack in Algeria. Simuliid attacks on livestock also can be severe. And when a female simuliid feeds on a host, it releases saliva to help with the uptake of blood. This saliva, when released into a host by many, many flies, can cause toxic shock, which is a condition known as simuliotoxicosis, and in many cases, it does result in death. There are 6 human diseases that are borne by simuliids, the most significant of which is the one I mentioned before, human onchocerciasis. There are also 6 diseases that are borne by simuliids to domestic and wild animals. And I am certain that 4 of these, at least 4 of these diseases and syndromes can be found in Algeria. Documentation at this point, for the most part, is lacking, but investigations, I'm certain, will show that 1 or more of these diseases actually do occur in Algeria. Specifically, avian trypanosomiasis, which is found worldwide, bovine onchocerciasis, which is found in many parts of the world, wild onchocerciasis. This is onchocerciasis that infects wild animals such as camels. Leukocytozoonosis, a very widespread worldwide disease exclusively of birds. And because Algeria has many species of birds, I am sure leukocytozoonosis is a problem in Algeria. Because human onchocerciasis is such a significant problem, it is worth asking the question, what is the potential for human onchocerciasis to occur in Algeria? The common name river blindness can be seen here. The condition of human onchocerciasis affects about 25 million people in the world, largely in equatorial Africa, the dark area on the map on the left of your screen. About 300,000 people are blind, permanently and irreversibly blind, and about 800,000 are visually impaired. Now, I would like to point out that I have indicated the distance from the infection zone to the border of Algeria is only 600 kilometers. And the distance from the infection zone to where you are today, where you are sitting today, is only 2,500 kilometers. So Algeria is geographically very close to these severe infection zones. We can look at this question, is human onchocerciasis possible in Algeria, from a historical perspective? And what we will find is that onchocerciasis came into many areas of the world from Africa. It came into many areas, it became established in many areas, such as South America, by the slave trade. Historically, and you can see some of these blue arrows going up into Algeria, the slave trade moved into North Africa, and with the introduction of the slaves came onchocerciasis. As far as we know, there are no documented cases that onchocerciasis that arrived in Algeria actually became established so that it was a self-sustaining disease. And that's fortunate. However, it's important to look at the possibility of onchocerciasis being a problem for humans in Algeria today. And I would tell you there are two mechanisms by which humans can be infected with with these parasites. In today's world, international travel is occurring on a very massive scale. The travel of infected individuals from infection zones to other parts of the world, including Algeria, brings the possibility of onchocerciasis entering your country. What would be required would be for an infected human who enters Algeria to be bitten by a simuliid, and then that simuliid to bite another person, and the cycle to establish itself in Algeria. I think the possibility today is remote, but it is something we must consider and to function proactively. The other way that onchocerciasis can become a problem for humans is through zoonotic cases. In other words, there are species of onchocerca that infect wild animals, camels, for example. If a simuliid feeds on an infected wild animal, acquires the onchocerca parasite, and then feeds on a human, it is possible to introduce that parasitic worm into the human and to cause onchocerciasis. There are a number of these documented cases in different areas of the world. So again, it is something that we must be aware of and to act in a proactive manner. The study and the eventual control and management of the simuliid begins with integrated taxonomy. What I mean is using information from as many sources as possible to identify species accurately and to discover new species, of which there are still many, including in Algeria. So we're talking about ecological characteristics that can be used for identification. Each species of simuliid has a specific habitat in which it lives and develops, a specific development time of the year, and so forth. So these ecological characters, this ecological information can be used for identification. Morphological identification, of course, is the classic means of identifying and discovering species. In the upper left of your screen, you can see the head capsule of a larval black fly. It has many excellent taxonomic characters. We also routinely use the giant chromosomes, the polytene chromosomes that are found in the larval salivary glands. These banding patterns are unique to each species. And of course, we use the molecular approach. We use species. But for simuliidity, one method is not sufficient. We must use an integrated, combined approach. There have been a number of excellent ecological studies of simuliids in Algeria, and I would encourage more of these ecological studies to be conducted. And, importantly, to begin using this ecological information for practical benefit, specifically to evaluate water quality. It's possible to use simuliid species as indicators of the health of flowing water. Each species of simuliid develops in a particular habitat. These simuliids are very sensitive to pollution. Different species have different levels of tolerance. And therefore, by evaluating the species of simuliids that are in each stream and river, we can assess the quality of that water. and the health of that water. So we're using a group of insects that typically is thought of as medically and veterinarily important. We're using those insects to help us understand clean water and to help us define clean water. Another important area of investigation in the world, and Algeria specifically, is to look at the natural enemies of simuliids. And these are commonly found. Any survey of larvae in a stream will reveal a number of natural enemies. In the image before you, you see example of larvae that are severely infected with a microsporidian parasite. Microsporidia are one-celled fungi. They attack many organisms, and they attack nearly all species of simuliids. In many cases, the simuliids have these large asymmetrical white enlargements of the body. The importance of looking at these natural enemies from a practical standpoint is that it offers new ways of potentially controlling simuliids. If we want to study the ecology of adult simuliids, if we want to understand the disease vector potential of simuliids, we need to trap the female flies. And there are a number of ways that this can be accomplished. Probably the simplest and most popular way of attracting and capturing female simuliids is with carbon dioxide traps. Carbon dioxide is released by all birds and all mammals, and it is used as a very strong cue by the simuliids to locate the host. A trap designed would simply involve a source of carbon dioxide, such as a bag of dry ice, which is suspended above a simple, commercially available mosquito trap. That's below the bag of dry ice. Sometimes that mosquito trap has a suction fan to draw the flies in as they are attracted to the carbon dioxide. And at the end of the day, you can empty the trap, and as you'll see, a 12-hour collection in the lower right image indicates that we have captured thousands of adult simuliids. Now, as I said, there are many ways to capture adult simuliids, to capture males and females for molecular work or for screening for diseases, or to determine development time of the day. You can do something as simple as placing some kind of a net on top of a vehicle and then driving around slowly on roads. Typically we drive at about 25 kilometers per hour, maybe drive for 20 to 40 minutes, and at the end of that period we will have collected quite a number of simuliids. I mentioned leukocytozoanosis as a disease that undoubtedly occurs in Algeria, although its documentation is minimal in the country. Leukocytozoan parasites are protozoa that are transmitted almost exclusively by simuliids to birds. Algeria is rich in birds. It has 445 species. Probably the vast majority are infected with these leukocytozoan parasites. When the parasites infect domestic birds, such as chickens, it can cause severe disease that results in death of the birds and certainly in economic losses. So it's an important disease. An infected, a simuliid fly will feed on the bird, it will take up the parasite will develop inside the simuliid will then take another blood meal on another bird, and it can infect that other bird. and so the cycle continues. This is a very rich area for investigation in Algeria, as I mentioned. So I would like to summarize my presentation by highlighting 5 opportunities for simulated study in Algeria. I've covered each of these in the talk, but just to re-emphasize and to highlight these areas. 1, there's a great need for integrated taxonomy of the simulates in Algeria. And not just Algeria, but all countries of the world. These 5 areas of investigation would apply. So the integrated taxonomy, the combination of ecology, morphology, cytogenetics, and molecular, to help us identify with great accuracy and discover new species. Second opportunity is that of biodiversity. Simuliids are a very diverse group, more than 2,400 species worldwide. This represents enormous biodiversity, and it's important to document this biodiversity. For example, simuliids, because each species is specific to a habitat, can be used to identify unique habitats, habitats that deserve conservation and preservation. So again, we can take a medically and veterinarily important group of insects and use them to human benefit by helping them identify habitats, particularly aquatic habitats, that require conservation. Continued ecological studies of simuliids in Algeria are important, and the transfer of this information to benefit our understanding of water quality, to use simuliids as indicators of water quality. A 4th area of investigation, symbiosis. Here I'm talking about those organisms that live on and within simuliids. This could be parasites, it could be commensalistic organisms. We need more information on these organisms that inhabit simuliids. And again, these parasites, these natural enemies or symbiotic organisms could provide new methods for controlling simuliid pests and disease vectors. And finally, we have the opportunity to study wild blood hosts. In Algeria, I do not think we know the hosts of any of the simuliid species in the country. What species are feeding on humans? We don't know. In your country, you have the iconic endangered species known as the Barbary macaque. The Barbary macaque, its numbers are decreasing, conservation efforts are in place, but we need to know what simuliids are feeding on these primates. What simuliid species are feeding on Barbary macaques and other birds and mammals in Algeria. This knowledge then would become a part of the larger conservation plan to help these animals. And finally, I would like to end with an image that shows you how beautiful simuliid diversity can be. This is an example of simuliid biodiversity. 4 larvae representing 4 species. And with that, I thank you very much. Again, Dr. Cheraria, thank you for the opportunity to join this conference today. I wish you great success and happy simuliid studies. Thank you very much.
Thank you very much, Professor Adler. Thank you very much for your very pertinent presentation, in which and with which you include all information about similitude in fauna in Algeria. Thank you for giving the community the opportunity to know what is similitude? What is the interest?
Mona, excuse me. I notice on my screen it says that Zoom is going to give me less than 1 minute.
Okay.
Then it will close.
Okay, I will see that problem. I will restart. Please stay with us, Professor.
Thank you. I will stay as long as I can.
Thank you. Thank you.
Mona?
Yes, Professor, I am with you.
Yes, I am here again. Thank you very much.
So we now open the discussion. If anyone has questions for Professor Adler, please. Yes.
Good morning. So thank you, Professor, for your presentation. I will have a quick question. So what is your opinion about the use of citizen science database for the early detection of similitude species, especially in developing countries? Thank you.
Mona, can you repeat the question, please?
Can you hear me?
I'm sorry, I could not hear the...
Yes, of course. You can come and ask your question from there. Please. Professor Adler, we will repeat the question.
Thank you.
Can you hear me? Okay, I hear you.
Yes,
I am hearing
yes, I
you.
can hear you. Thank you.
Presentation. My question was, what do you think, what is your opinion about the proposal of using citizen science database for early detection and monitoring the spread of similitude species? Thank you.
Yeah, that is an excellent question. Thank you very much. I am a strong believer in citizen science. There is a model of citizen science that has been in place for medically important insects, specifically for mosquitoes in a number of countries. And Germany, for example, has an outstanding citizen science project that involves sending mosquitoes by the public to a central receiving facility where those specimens are identified and then screened molecularly for diseases. What that requires is a lot of work by a central receiving agency where somebody will be dedicated to doing the identifications and then, if desired, to doing the screening for any disease organisms. So the opportunity certainly is there. It can begin with something as simple as citizens collecting simuliids. Perhaps they're feeding, the simuliids are feeding on the individual, or perhaps they're feeding on their pets or their domestic animals. They can be captured, sent to a central receiving facility where identifications could be made, and then those identifications go into a database that is available on the internet to anyone that is interested. And as the database becomes enriched with more and more records, we begin to see the patterns and can document any spread of simuliid species, for example, with respect to climate change. Thank you.
Thank you, Professor, for your explanation. More questions? Okay. Professor, you will be asked by Professor Osman from Egypt. Professor Osman from Egypt. Please.
Yes. The simuliid studies that I have discussed have gone from, since the beginning of research efforts to today, to the present time. Yes. So it covers all time of recent scientific investigation, ecological studies that have been done in Algeria, and Morocco, across North Africa, have mostly been done since about the early 2000s. So that information is available on the internet. There are no ecological studies on simuliids in Egypt that I am aware of, and very few in Tunisia. Algeria is where most of the ecological work on simuliids has been done. Thank you for the question. I hope I answered it for you adequately.
Thank you so much, Professor. Okay. More questions? Yes?
Samba, one question to Peter.
Yes, of course. Yes, you can Samba ask.
Hi, Samba. Denise.
Thank you, good everybody, and Peter, thank you so much for this presentation and the clarity of the information you gave to us. That was really important. So I only have one small question, like this, about the human migration, because people are moving around the country. So we have seen that there is a huge number of people moving around, and I would like to know that there is a risk for unconcealed cases to spread in some countries where we haven't seen it, like in Nigeria. How the medical anthropology, what I would like to know, like how this process occurs. Like for example, there is a vector who took the parasite. Like for example, for parasites, normally, if I'm not mistaken, normally the vector is simulum damnosen. Let's say in Nigeria, they don't have simulum damnosen. If there is a chance for another vector, for another species to become a vector of that parasite, and how it happens.
Very good question, Samba.
Yes.
Congratulations.
Yeah, thank you, Samba. That is an excellent question.
Yes.
So the quality of the vector must exist in order for onchocerciasis to become established. A suitable vector must be found. But about 400 to 500 years ago, when onchocerciasis was being moved around the world with the slave trade, it came into South America. Simulium danosum and related species are not found in South America. And yet, onchocerciasis was established in multiple locations for hundreds of years until it was just recently eradicated because other species served as suitable vectors. And these were species of simuliids that had no relationship to the African vectors, the Simulium danosum group. So potential vectors exist everywhere in the world. Honestly, we do not know what makes a suitable vector. And so in Algeria, we cannot say this particular species would be a suitable vector. Those studies have not yet been done. And that is part of the danger or part of the risk, because really we're just sort of looking at this blindly until those kinds of studies can be done. But the risk potential is certainly going to increase because, as we all know, international travel is increasing at such a rapid pace.
The question is, who will do all this work? Only Nigeria.
I think I'm looking at the people who will do this work.
I hope. I am inviting. I am.
Mona, you can do that.
Yes, I will do. I will do that right now. I am inviting all people to work in simulids because yes, I don't know who will be interested in working in simulids because I am the only researcher working in simulids in Algeria. And I can tell you there is a big problem in Algeria. As Professor, can I talk, Professor Adnan?
Please, yes.
Is there any more questions? No questions? You have one more question, Professor Adnan.
Very good. That's an excellent question. In fact, the answer is just the opposite. Simulium larvae in streams everywhere in the world provide a benefit to the food web. They are used by fish of many species as food. They're used by other aquatic invertebrates in streams as food. So simuliids often represent part of the base of that food web, a very important and integral part of the food web. If you remove simuliids from a stream, then you are potentially decreasing the biodiversity of that stream and potentially decreasing the water quality.
Thank you. More questions? Is there any? So, indeed, Professor Adnan, I don't have a question for you, but I will talk about the problem with simulids in Algeria. Indeed, it's very serious because, as you mentioned before, we have almost 6 species implicated in human disease in Algeria. And we have a big lack of data and information regarding simulids, habitats, ecology, blood, feeding, host preference, And this is a problem because, as we mentioned before, indeed, and unfortunately, we do not know yet what is exactly the host of syphilis in Nigeria. Because the problem is to control syphilis, we need to begin with an integrated approach, including cytogenetics and molecular techniques, such as DNA barcoding theory, as we do with Alpha. So we have to highlight the problem with syphilis in Nigeria. We need people working in Nigeria because, as you mentioned, we have 545 species of birds. It's a huge biodiversity, and we know that syphilis, we have many ornithophilic species, and this is a big problem. Big problem. Not only for the species feeding on livestock, but in general, we have a big problem of human health and zoonotic problem. And we have to say that it's still a big effort to make to solve this problem. I am perfectly with you. Continuing our studies and will help us to increase the number of species implicated in transmission and to know what is the potential vectors in Nigeria. It's a big work to do, and I hope people will be interested. I have already two doctoral students working on this field. One of them is here, Bohro. So the problem is that in Nigeria we don't have a similar domination, but the central point in Mali, which is the southern part of Africa, is very near to Algeria. So the question mark is, do we have similar domination? And the investigated region in Algeria is only limited in the northern part of Algeria and in the small part of the eastern part of Algeria. And we need more efforts to investigate more regions of Algeria, as that did our colleague Boutaina Belkat in Morocco. So the biodiversity in Algeria of syphilis is about 33 species. If we compare this biodiversity with Morocco, it's not enough. It's not enough. We need that Algeria have a high endemicity. Results obtained within our publication show that we need more efforts. So Algeria is very rare. Not only investigate near mountains, and maybe the next point will be Niger. So I have to say thank you so much for what you did for similidifona, Algerian similidifona. Thank you so much for all you did to discover the people what is the biodiversity of similids, and that's it. Thank you so much, Professor Albert. Thank you so much. We need to hear you more.
I'm fine. I will enjoy the conference while in the time that I have remaining.
Okay. I will make you breast next time.
Thank you.
As you said, we said. Thank you so much, Professor, for giving us this honor. It's a huge honor for all of the Syrian community, especially in Ghana University. Thank you so much.
It is a great pleasure to join you. Thank you.
Thank you so much. We are going to eat. Everybody is. So I am seeing that beyond.
It is dark.
Thank you so much for your effort. Thank you much for giving us this opportunity. I know that internal it is about maybe 8:30.
About 7:30.
7:30. So we speak about that. I apologize. I really apologize for making you wake up too late.
No.
Wake up too
It's,
late.
I am awake. It's not a problem.
I know. You are always awake. Thank you so much. Thank you. Thank you.
You're welcome.
We need to leave now. Thank you so much. I will keep in touch as usual. Thank you so much.
Thank you very much. Enjoy the conference.
Thank you.
Enjoy the lunch.
Thank you. Thank you. Thank you.
Goodbye.
Goodbye. Alors, donc, c'est pas à moi de déclarer la session des plénières clôturée, mais je suis obligée de le faire. Alors, donc, j'invite les communicants ainsi que les membres du comité scientifique ainsi que les membres organisateurs d'aller joindre le déjeuner qui va avoir lieu au niveau de la faculté des sciences de la nature et de la vie. Donc, il y a des indications pour les gens qui font partie, qui ne connaissent pas les lieux. Et on a envoyé le GPS dans les emails. Donc,